Good morning, students. We are still on partial fraction. Now we are on the second video number 2. Guidelines for solving partial fraction problems. Guideline number 1. The numerator of f of x, of the given rational function f of x over g of x must be of lower degree than that of the denominator g of x. On the contrary, if the degree of the numerator f of x is equal to or higher than the degree of the denominator g of x, then first of all, divide out by long division. After long division, that is, after division, we have a quotient and the remainder. It is the remainder over the divisor, i.e. the denominator of the given rational function, that is now resolved into partial fractions. Example 1. Express x cubed plus x squared plus 4x over x squared plus x minus 2 into partial fractions. Solution. The first thing we do here is to compare the degree of the numerator with that of the denominator. If you compare, you discover that the degree of the numerator here, we compare the term with the highest power, which is x cubed, is higher than the degree of the denominator, which is x squared. So we apply guideline number 1, which says we must divide first. So here we apply this guideline number 1 by carrying out long division. Is x cubed x squared plus 4x plus 4x divided by x squared plus x minus 2 plus x minus 2. X cubed divided by x squared is x. I hope you still remember your division of polynomial. X times x squared, x cubed. X times x squared. X times minus 2, minus 2x. Then subtract. X cubed minus x cubed is 0. X squared minus x squared is 0. 4x minus 2x will be plus 6x. So 6x is a remainder. It means that you now have x cubed plus x squared plus 4x over x squared plus x minus 2 is equivalent to this x plus 6x, which is the remainder, over the divisor, which is x squared plus x minus 2. So what I'm saying that it is this 6x over x squared plus x minus 2 that you now resolve into partial fraction. We now resolve we now resolve 6x over x squared plus x minus 2 into partial fraction. Into partial fractions. Now, 6x over x squared plus x minus 2 is equals to, here, you look at the denominator. The denominator is a quadratic factor. So we have to factorize it into its linear factor if it is factorizable. But here, this one is factorizable, so we factorize the denominator into linear factor. That will be 6x over x squared plus 2x minus x minus 2. So factorize each group. Factorize each group. This is the same thing as 6x over x into x plus 2 minus 1 into x plus 2. This is the same thing as 6x over x minus 1, x minus 1, x minus 1 into x plus 2. So, the denominator has been factorized into its linear factors. So the next step is to say, let 6x over x minus 1 into x plus 2 be equivalent to a over x minus 1 plus b over x plus 2. Clear the fraction. Clear the fraction by multiplying through by the LCM. By multiplying through by the LCM. By the LCM, which is the denominator of the left hand side. So if you do that, I'm left with 6x is equivalent to a into x plus 2 plus b into x minus 1. Now, how have I arrived at this? That is 6x over x minus 1 into x plus 2 times that denominator of the left hand side, which is still x minus 1 into x plus 1. They cancel out, so I'm left with only 6x. A over x minus 1 times x minus 1 into x plus 2. X minus 1 will cancel out, so I'm left with x plus 2. That's why I'm having a into x plus 2. The same thing with b. X plus 2 will cancel out, so I'm left with b into x minus 1. I can call this one equation 1, just for reference. So I now pick values of x that will eliminate each of these two constants at a time. Choose a value of x that will eliminate each of the two constants. Each of the two constants a and b at a time. Now, put x equals 1. Put x equals 1 in equation 1. So if you do that, the left-hand side will be 6 into 1 is equals to a into 1 plus 2 plus b into 1 minus 1. Therefore, 6 is equals to a into 3 plus b into 0. 3a is equals to 6, or a equals 2. A equals 2. Put x equals minus 2 in equation 1. So I have at the left hand side 6 into minus 2 is equals to A into minus 2 plus 2 plus B into minus 2 minus 1. So I have minus 12 is equals to A into 0 plus B into minus 3. Therefore, minus 3B is equals to minus 12, or B equals minus 12 over minus 3, and that is 4. So the values of constants A and B are now known. A equals 2, B equals 4. Therefore, my partial fraction, that will now be x cubed plus x squared plus 4x over x squared plus x minus 2. That will be equivalent to, but I had the quotient, which is x plus a. My a here is 2 over x minus 1 plus b, which is 4 over x plus 2. This is my answer. So my answer now is x plus 2 over x minus 1 plus 4 over x plus 2. That is my answer.